All right, so we're going to start with practice C. And we'll do problem number 4. So number 4 says, suppose a treadmill. So we're always going to write our given. And then we want to write what we want to find. Remember, whenever we read a problem, we're going to chunk. So we're just not going to read the whole problem. It makes it a lot easier as we read it to write down one thing at a time. So a car enters a freeway with a speed of 6.4 meters per second. So if I'm not sure, speed to 6.4 meters per second. Now maybe I'm not sure, is that like, since that's what it's entering, that's going to be my initial velocity. It accelerates. Now, if I'm not sure what a variable is, the trick is you look at the unit. Because if I look at the unit, I know meters per second is velocity. So you're not just memorizing units to write at the end. It helps you to identify, because sometimes things are not obvious. Okay? It accelerates at a uniform rate. Oh, no, I'm reading the wrong problem. Oh. What am I? Okay, so 6.4 meters per second. It accelerates uniformly for 3.5 kilometers. 3.2. Now we know kilometers measures x in 3.5 minutes. So t is equal to 3.5 minutes. I'm going to highlight this problem because my eyes are skipping and I want to make sure I'm doing the right one because I kept skipping between C and D. Okay. Now before I even go on, I'm going to look at this. I'm going to say, wait a second. This is in meters per second. This is in kilometers, and this is minutes. So I know that my units need to be the same. So I'm going to convert the kilometers to meters, and I'm going to convert the minutes to seconds. And I would do it on the, do it before I start doing anything else. So if I have 3.2 kilometers, now remember, when I convert, I can put this in the numerator. And if I want to go, if kilometers is in the numerator, I put it in the denominator, and I want to go from kilometers to meters, and there's 1,000 meters in a kilometer. So this cancels with that, and I end up with meters, which is my correct unit. And then I multiply 3.2 times 1,000, and I don't even need a calculator for that. I could just go 1, 2, 3, and I didn't even need to do it this way. I could just move my decimal point over 3 places. Then I have 3.5 minutes. So I'll put that over 1. If minutes is in the numerator, I put in the denominator, and I want to go from minutes to seconds, and there's 60 seconds in a minute. So I end up with seconds, which is my correct unit for time, and 3.5 times 60 is 210. A lot of times it's good to do mental math to check your work, because you could just say like 6 times 3 is 18, and then a half. So 60, a half of 60 is 30, so you could say 180 plus 30. So it's always good to do mental math because we can press the wrong buttons on our calculator to check your work. I do it all the time. All right, so now let's get back to the physics problem. Well, it says that, now let's read the rest of the problem. It says how fast in meters per second. So I want to find VF. Is the car moving after this time? Now remember, there's a way that we remember the formula that, so I have VI, I want to find VF, X, and T. So now I'm going to say to myself, which equation has those 4 variables? So the equation that has these 4 variables is the one that says x is equal to 1/2 VI plus VF times T. Now this is where people make a mistake. So many of your teachers teach you just plug numbers in the formula, and when you do that, you don't have a foolproof way to check your work. And then you make a mistake because you're actually doing algebra on your calculator in your head. You're not doing it on paper. The more you write down on paper, the less likely you are to make a mistake. So what I'm going to do is I want to solve for VF. Because see how there's like a plus sign there, there's a multiplication there, and then there's another thing there? So I'm doing all that on my calculator if I plug in. And I don't want to do all that on algebra on my calculator. I want to do it on paper. Because when I do things on paper, I don't make a mistake. So this is my unknown, okay? So now, the first thing I might want to do is I want to get rid of that 1/2. So the way to get rid of a 1/2 is I multiply both sides by 2. So I'm going to have 2x is equal to VI plus VF times T. Now remember, I want VF by itself. So because T is multiplied times this whole quantity, what I'm going to do is I'm going to divide both sides by T. So I'm going to have 2x over T is equal to VI plus VF. Because I'm going to tell you right now, if you tried to solve for VF and you plugged your number in here, probably half of you are going to end up with the wrong answer. So I'm close. So now I want to solve for VF. So because this is a plus sign, if I want to get rid of this VI, I have to subtract it from both sides. So now I have 2x over T minus VI is equal to VF. So what you see here now is I have my unknown in terms of my known. So now when I substitute in my values, 2 times 3200 divided by 210 seconds minus 6.4 meters per second. And remember, you can't add apples and oranges. So now, when I'm performing the subtraction, I have meters per second and I have a meters per second. So I can subtract. So now when I do that on my calculator, my final answer should be 24 meters per second. And now I see, I didn't make an algebra mistake. I didn't forget to do some algebra in my head. I did it all on paper. So you know what? Maybe it took an extra 30 to 45 seconds to write some of this stuff out. But you know what? Now I'm going to get the correct answer. All right, let's move on to part D. We'll do one of those as a problem. So we'll do D3 because I think that one's the hardest. So now we're going to, now what I would do for this is maybe go on the back of the piece of paper because I want all practice C together and practice D. A lot of times we don't do 2, but these are both short. So like now start on the back, and on the back write practice D. And now we're going to do number 3. So remember, we're going to chunk and we're going to write stuff down as we read it. So again, we want to write our given. We want to write what we're going to find. So we're ready to go once we start reading. So it says a car starts from rest. So the first thing I'm going to write down is VI is equal to 0. Starting from rest, that's what that means. So remember, in physics, we read words and it has a meaning. It travels for 5 seconds, so T is equal to 5 seconds, with a constant acceleration, so A is equal to negative 1.5 meters per second squared. And if I wasn't sure what a value is, I just look at the unit. Meter per second squared measures acceleration. Time is measured in seconds. So now it asks me 2 things. It says, what is the final velocity of the car, VF? And it says how far does the car travel in this time interval. So I want to find how far it went, x. So let's start with the first part. So this is how we would distinguish which equation to use. So first I see I have VF, B, I have A. All I'm doing is writing what I have in my given over here. And now I'm going to write down the first thing I want to find VF. So these are my 4 variables. This one's going to be which equation has those 4 variables. So the equation that has those 4 variables is VF is equal to VI plus AT. Now it's already rearranged the unknown in terms of the known, so I can substitute in. So VI is equal to 0 plus negative 1.5 meters per second times squared times, and you know what, let me write this over and I'm going to show you why. Negative 1.5, instead of me doing the slash, I'm going to do it like this, meters per second squared times 5 seconds. And the reason I wrote it over is, instead of remember I told you if you carry your units through, it's a foolproof way to check your work in physics, so you always want to do that. So if I write this unit with a horizontal line, I can just do that right in my work. You see how, everyone look up, see how this second is going to cancel with that? And now I end up with meters per second. Is that the correct unit for velocity? It is. So that took me like a couple of seconds, and I have a foolproof way to check my work to see if I end up with the right thing. So then negative 1.5 times 5, VF is equal to negative 7.5 meters per second. Now when we talk about positive and negatives, we're going to do graphical representation of motion later on in the week, and then we'll see conceptually when we look at a graph, some of the things like this that are negative will make more sense when you see how something's moving. Now we still have to do part B, where we want to find x. So now there might be more than one way to do it. I have VI, I have T, I have A, I just found VF, and now I want to find x. So now I have choices. Now there's more than one way to do this problem. Now in this section, we haven't learned there's another equation we're going to learn tomorrow, so I'm not going to do it that way. In this section, practice D, the equation that they use on some of the problems is this one. X is equal to VIT plus 1/2 AT squared. And the reason is, and let's pretend we didn't find VF. You see how now I'm using what's in my given, and what I want to find, that equation has those 4 variables. See how this equation has X, VI, T, and A? So I'm directly using it. Now the equation we're going to learn tomorrow, we could have used this answer and found it, and then sometimes you can check your work because you can do it more than one way. So since I'm finding X, I'm going to substitute in my value. So VI is 0 times T, which was 5 seconds. Now let me show you a trick. What is 0 times anything? 0. So whenever I know VI is 0, instead of writing this, that's a waste of my time. What I'm going to do is, and this is what they do in college classes, you do, and you can do it in the same color, but I'm just going to do it in a different color. So you do an upward arrow to the right, and you put a little 0, and that means that whole term goes to 0. That whole term disappears because anything times 0 is 0. So now our equation just becomes X is equal to 1/2 AT squared, and I just got rid of that whole term. That whole term disappeared. Now it's easier to just substitute in here 1/2 negative 1.5 meters per second squared times T squared, which is 5 seconds squared. Now, this is another place where people make a mistake. This whole thing is squared. Whatever mathematical function I do to the number, I do to the unit. So let's just look at the units first. I have a meter per second squared, when I square this 25, I also have to square this second, so this becomes second squared. Now, if you look, this second squared cancels with that one, and I end up with meters. Is meters the correct unit for displacement? It is. So now I have, again, a foolproof to check my work, so when I do it, unless I'm a fool and I don't want to check my work. Okay? But if you want to get an A in the class, you will just do that extra couple of seconds to check your work. So then 25 times 1.5 divided by 2 so it comes out to be 18.75, but I'll put it in two significant figures. So 18.75 meters, so my final answer is going to be 19 meters. And it's going to be negative, because this is a negative. So even though, I don't want to forget my negative sign and put that in here. But the problem didn't ask for the displacement, did it? It just said how far does it go. So your final answer could just be 19 meters, because they didn't ask you like which direction it went. Okay? So that's why on the sheet it just says 19 meters. It doesn't have like the negative sign. Does that make sense? Because it just says how far.